Hello everyone, good morning.
Hi, good morning.
How
Good
are
morning,
you?
Vikrant.
So let's wait for another 2 minutes and then we will start. I think yes, we will utilize this time for our discussions. Do you guys have any questions on our previous classes?
Yeah, because there were two methods for list, like reverse, and then there was another sort, reverse, true. So
Hmm?
both give the same results. Is there any difference between these two?
Difference is that in the sort we have two words, that is ascending and descending. Okay. So when the people said you to like do the sort in a descending order, then you can use that reverse. Okay. Then if you have a task to just to reverse the string, like however it is, whether the values are sorted or not sorted, if you want to reverse the things, then you can just reverse it. You got my point? Let's
Okay,
say
okay.
you can just assume in a list you have values like, let me share my screen to give the clarity of that. Is my screen visible?
Yeah,
Yeah, I think you can see my notepad,
yes,
right?
yes. Yeah.
Okay, you have an example. Oh, very fine. Yeah, you have an example of I can say let's 1, 2, 3, 4, 5, 1, and 2. Okay, this is the one example. Then another example. Okay, just you can tell me the output if I use a reverse.
So if we use reverse, it will be 5, 3, 2, 2, 1, 1, something like that.
No, it's just a reverse. It's not doing any reverse. Just a reverse. It means it will do only 2, 1, 5, 3, 2, 1. It's just doing a reverse. Is the values in the sorted order either ascending or descending? No. Reverse means it's just doing a reverse. In sorting reverse, it will do.
Okay, acha. It's reversing it, and it's like a mirror image sort of. Okay.
Yes. What it will do now, if it is in the reverse order, this will print the value in the descending order. There is a difference, right? For this
Okay,
output
okay.
and this output.
Okay, okay. Yeah, that's what I was a little confused here. Like I got it now.
Yeah, that's okay, fine. So now it's clear, right?
Yeah, yeah, yeah.
So any other questions? Okay, if no questions, then we will start with our actual topics. So after the data structures, right? So I told this list is consumes a huge memory. When you have a big array, like somebody of you are already familiar with arrays, right? Arrays is nothing but uh, a sequential arrangement of the items separated within a comma and enclosed with one enclosed within a list kind of data structure, right? That is again simply array. It is array means in mathematical representation. Okay, so before coming to Python or whatever the language, whatever the technology it is, from the mathematics perspective, so this is just an array. Okay, this is just an array. But nowadays, the Python peoples are used to call this as a list, right? Array means it's just as an array. So I think if you guys are already familiar with an mathematics, okay, what you can say, linear algebra, okay. So those people knows that matrix kind of things, right? How the matrix works: 2x2 matrix, 1x2 matrix, 3x3 matrix, right? How this looks actually: 1, 2, 3, then enter 4, 5, 6, right? What is the shape of this matrix? Come on.
It's two-dimensional.
No, you can just mention it in a 2x3 or 3x2, like 3x3 or 1x2 matrix. Sir, I'm not talking about any dimensional, any coding things. I'm
So
just
it's
talking
two by
about
two by three, 2 by 3.
2 by 3, 2x3 matrix, right? And so in this way also we can store our data, right? So in Pythonic way, we are call this as a list. This one we call it as like a two-dimensional list, right? So if we want to bring this matrix in a list format, so what we are going to do, we are going to mention the list inside of list. Correct? Correct? Right? 2x2 kind of thing. So list inside of list, we are going to call. So again, finally, in Python perspective, it's a list only. It's a list only. So in mathematics, we are call it as just an array. So this is the only difference when I bring the word as array and list. Both are same only, but the a, a base concept, not a base concepts of both, it's a different thing. So in Python, what happened? It is going to consume some more memory, lots of memory. If we have 100 millions records, 100 like 1,000 rows, sorry, 1,000 items in a one single row, one single dimension. What happened? This Python list is going to consume a lot of memory to access that. Correct? So in that case, how we can avoid it? What is the alternative for that? Very basically, what is the alternative for that? Either we should use
Vikrant, I'm not able to hear you. Are you audible?
can you guys can hear my voice?
Yes.
Yes, yes, sir. Yes.
I think I lost some seconds. So yep. So first we need to think of whether it is possible to use any other data structures or not. So usage of any other data structures, let's think about sets. So sets have their own limitation that it won't allow you to duplicate the record. If you are okay with that, you can use it. We don't have any objection to that. If you are like, if you want to have some repeated and duplicate records in your data structure, then sets will not work out, right? Then other terms, then other data structure is a dictionary. Dictionary, it's a mapping kind of things. Okay, so you are having some arrays. Okay, this is not a key value page. So in that case, dictionary also rejected. Then another data structure is tuple. Okay, you can use the tuples. It will allow you to have the duplicate records, and it will have the sequential values like series of values. Everything is okay, but if you are okay to have it in a immutable stage, means once it is created, so if you like, you don't want to alter it. So if you just want to create it, after that, if you don't want to make any changes of that particular data structure, you can still go with an tuple. But if you really want to do any changes in future, then the tuple will also not a good data structure to store that 100 items in a list, in a data structure. Then how we can go ahead with these kinds of scenarios? What is the alternative for this list? So for that only, we have another Python built-in library that is third part, that is not actually a built-in library, library that is NumPy. So by using this NumPy library, you can create any sort of array by understanding the transformations in the NumPy array, you can achieve anything. Like whatever you are going to do with the list, so all the things you can do it in a NumPy arrays also. Okay, so let's go with that. Like how we can, because it's a third-party libraries, how I can install it and how we can play around with that. Okay, so let's get started. So very firstly, you need to open your Anaconda from your local system. Okay, you need to check whether you have a NumPy or not. So for that, you can just run the command pip install, and you should specify the package name, that is NumPy. If you are not specified any version, then it is automatically going to take a latest version of NumPy. Okay, so I'm also not going to specify any version because I need a very latest version. So I'm just pressing enter here. So requirement already satisfied, NumPy. It means this package is already available in my local system. If not available, it's started downloading that package and installing it in your local system. See, I'm just using 1.23.5. This is the version name of that NumPy. Yeah, somebody is asking something. Please go ahead. Then, so once you have executed this pip install NumPy command, here only you can check it whether your installation got successful or not. Okay, just write a command Python and press enter. Now you can just pass the Python code, that is import NumPy. This is the way, right, to import the libraries. You can just execute that line of code. So if you are executed that line of code without any exception, without any error, then it means you are successfully able to install that library in your local system. So this is the way to download any of the packages. It is not only dedicated for NumPy, any of other packages also you can download in the same way. Okay, so I'll just exit this prompt, that Python, and just came back to my shell from Python environment. Okay, so once it is installed, it's your choice. You can just close it, that Anaconda. And now we can go to our notebook and let's see how we can import it and all. So before that, so the same example which I have given, right? The same things, the list and matrix, like how it is worked and all those things. So let's understand some characteristics and some use of NumPy. NumPy is a Python library used for working with arrays. And it's also as a function for working in domain of linear algebra, Fourier transform, and matrices, right? So matrix and these concepts will comes under linear algebra and Fourier transformations and matrices. So in that situation, this NumPy will help in those sort of calculations. Okay, NumPy is an open source project and you can use it freely. So as I told, Python is always open source and the packages available with the Python, those are also free. This is again an open source project. You can use it freely. And NumPy stands for numeric Python. So you can see what is this name stands for. NumPy means it's just a numeric Python. It's like NumPy is only deals with a numerical data mostly. Okay, this will not work out if you have any text data. In those scenarios, it will not work. But if you have a numeric data, if you are doing some complex mathematical logics, then you can use this NumPy. Okay, then why to use NumPy? So in Python, we have list that serves the purpose of arrays. Okay, but they are slow to process. As I explained, why it is slow. NumPy aims to provide an array object that is up to 50x faster than traditional Python list. You can just imagine how fast it is then compared to traditional lists. Okay, so this is also one of the reason why we should learn NumPy. The array object in NumPy is called ND array. Okay, it is means n-dimensional array. Like n means like whatever the number which you are going to assign, you can assign in 2-dimensional array, 3-dimensional array, whatever it is. And it provides a lot of supporting functions that make working with ND array very easily. As I told you, also can do the same sort of transformation with NumPy methods. NumPy is also providing multiple methods, okay, for transformations. Arrays are very frequently used in data science, where speed and resources are very important. Data science, okay. Why? Because data science, again, these algorithms are placed around with the numerical values. Okay. The machine learning algorithms are based upon some complex mathematics, logics, and those concepts. Okay. Then, and where the speed and resources are very important, then there also you can use this NumPys. Okay. This is how this is the reason we need to learn NumPy in Python. Okay, this is the most important and the most required libraries in the market. Okay, so let's see how we can install it. You can just pass this command. Okay, pip install NumPy. So to install it in your locals, once you are installed, you can test it in your Python environment and in the notebook as well. So here you can see import NumPy as NP. In means, so instead of using this big name, okay, instead of writing this NumPy name, so I can always rename this NumPy as an NP in our working directory, in our working environment. I'm just importing this NumPy with the name of NP. That's it. Let me execute this line of code. Then if you really want to check on which version you are working, so you can see NP dot. This is the private methods which we have, that is version, to check the um, version of the NumPy. Okay, so you can see 1.23.5. This is what we already seen in our Anaconda shell. Okay, so let's create one array by using NP. I have a list. Okay, I have a list. 1, 2, 3, 4, 5, 6. How I can convert this into NP array? How we can convert it? You can call NP dot. You can just press a tab again, so you can see how many methods is available, on which function you need to use. We have so many functions, classes was there. So okay, so I'm just going to show like how we can create arrays, and what are the dimensional, what are the calculations, like how we can achieve our goals, but like whatever we achieved in the list. So this is what I'm going to show in these classes. Okay, let's see NumPy dot. So I wanted to convert this as array, right? You can just type array. We have array. Yes, we have array function. You can just call that function, and you can just press a shift tab again here to understand, to see the documentation of that. What are the parameters available inside of that array object? Like what is the object? It's an array like object. Array like means, so the values like separated within a comma in a series. The value should be in the series, right? And data types, none, copy is true, order in K, and sub false, and n dimensional is 0, and like is none. So these are the arguments. If you guys have more interested on the other arguments as well. You can go through with this document and you can just understand that what that each and every argument tells about that. And maybe this should also provide examples as well. So whatever I'm going to like showing to you, so those are all already showed up as an examples. Okay, you guys can always see that numpy dot array, how you can create your array. So this is the result and numpy array and upcasting. Okay, numpy dot array, like you can see it's in the different data types. Okay, it's in the float kind of thing, float data types, because we have that point values. More than one dimensional, like how we can create it. Minimum dimensional is 2. How we can specify that n dimensional argument to provide that 2-dimensional array, and complex logic, like how we can convert into data types as a complex, as you are already aware of what you mean by complex values, and like how we can define the data types of for that. And these all things we have. These are the multiple examples which are multiple values. Okay, sub okay is equals to true, what it will do. All of the we have multiple examples over here. So this is what I'm expecting from you all. Like you should explore your own these libraries. Then only you got some multiple questions and you have got some multiple solutions as well. So I'll also execute some of the codes from there. Okay. So I'm just provided an object over here, np.array. This is my list. I'm just going to convert this into an array. So see, this is what it is. So if you really wants to check the type of that is array only. See, that is numpy nd array. It means n-dimensional array. This is the type of this np.arrays creation. This is how you can create an array. So see here, I've just given a multiple examples over here, like how you can specify the data types for that each of every values. So all the values are gets converted into complex type. Okay, and multiple examples over here. Okay, and you can go with those examples and check what it is doing. Just providing object is 1, 2, 3. Let's go with some examples of those things. Yeah, n-dimensional, you can see. This is the example which I'm going to check. The same example I'm going to explain. So n-dimensional. See, now okay, what is it? P. It's NP. See, it's a list inside of list. What happened here? Okay. So 1, 2, 3. This one list is converted into 2-dimensional array. Like how I can say the 2-dimensional array. So see, as I told, it is list inside of list. So now it is in the 2-dimensional array. If it is in a one single square bracket, then we can call it as a 1D array. Okay, because it means one row. It's a simply one row. If it is in the 2-dimensional, like if we have a different values, how it looks? 1, 2, 3. Okay, then 4, 5, 6. This is how 2-dimensional matrix looks like, right? Because it's in the format of in the format of rows and columns. So you can see these are the columns, these are the rows. So you can say that it's in the 2-dimensional array. We have rows and columns kind of things, right? In the same way, because we have only the same values, 1, 2, 3 gets converted into 2-dimensional array. If I just check this as a 3, then what happened? This is going to convert it into 3-dimensional array. See how I can check the outputs within on which dimensional our output was there. Here we know that we are provided n-dimensional is equals to 3, and now it is in the 3-dimensional. How I can check this in a programmatical way? For that, so we'll go with our data dimension sections. So you can see what I mean by 1D array. One-dimensional array can be defined as follows. The most basic type of array is one-dimensional array, as you guys are already got to know that, in which each element is stored linearly. Okay, each elements are stored in a linearly and may be retrieved individually by providing its index values. So you can understand that, right? All the items are linearly arranged. If you want any element, if you want to take any elements, if you want to retrieve any element, you can retrieve it by using that index position of that array. Okay, here also that index position concepts will works. And a collection of elements with the same data types that are kept in a linear arrangement under a single variable name is referred as a one-dimensional array. Okay, so this is what, like whatever the examples which I have given till now, those are all one-dimensional array. What do you mean by two-dimensional array? The two-dimensional array can be defined as an array of arrays. As I told it, right? It's a list of lists. In a list concept, it's a list of lists. But in the arrays concept, it's a arrays of array. Okay, both are looks like the same. But whenever you are bringing the array word, so we are just going to convert that into an NP arrays. Then the type would be changed to NP array from list. Okay. Now here we are going to call this as an array of arrays. Okay. The 2D array is organized as a matrices, which can be represented as a collection of rows and column. So you can always see that. You can always see in that. So we have rows and columns. It is in the table format, right? You can always store the values in that particular format. Okay. However, 2D arrays are created to implement a relational database, look like a data structure. Relational database means in the relational database we have a structured data only. It means it consists of rows and columns. So in that kind of scenarios, we are going to creating this 2D arrays. Okay. It provides easy of holding a bulk of data once which can be passed to any number of functions wherever it is required. So as I told, if that's it's a very easy to maintain the structural data. If you have a bulk amount of the data, you can always save it in that format and it is easy to maintain it. Okay, that's why this 2D array is very important. And so you can see it's a arrays of arrays. Array of arrays. Okay. So how we can convert it? It's you can use np.array. You can just execute this line of code. You guys can see like how it looks. For whoever don't know about this NumPy, for all the people going to identify this as a list of lists, but it is arrays of arrays, array of arrays. You can just check. You can just always check the type. Okay, you can always check the type. See np.nd array. Okay, why? Because we are just converted that in an np.array. In the same way, right? We are just used int function and string function to convert the data types. In the same way, we are converted that list type into np.array. Then once you are converted that into np.array, to make a transformation of those particular data, we have that numpy arrays methods only. So that list method, whatever the Python built-in methods will not works. Okay. Then if you really want to check the end dimension of that particular output, dimension of your input, you can always go with dot ending. It is not in a function. How to know that whether like which names is showing a function or class, whatever it is, like how I can understand it. You can just always press a tab and you can just check end dimensional and this is instance. If it is instance, don't provide the parenthesis at the end. If it is a function, then only you should provide it. Okay. Let me execute this line of code. You can see this is a two-dimensional array. Got it, right? And if you really want to convert into any other different ND array, if you like. Okay, I'm not going to say 2D or 3D or something like that. ND array. Like based on your requirement, you can just pass that number 2 or 3 or 4 and you can convert it. How we can convert it? You can just use n dimensional. N dim is equals to 5. Then what happened? This 1, 2, 3, 4 gets converted into 5-dimensional array. You can see. So it's array inside of array, array inside of array inside of array. Like that, it went for 5 deeper loops. Okay, in depth. You can see this how it looks. Okay, this is what the dimension of the arrays, np.arrays. Any questions so far?
What is the use of this n-dimensional array?
Good question. So in the list, what happened? So you are only going within one sequential order. Like it's just replacing the list. Okay. So in this sort of things, okay, where we have list inside of list, list inside of list. At this moment, we have only two lists. Okay. But in the future, in your career, you may get a good data, okay, from your clients or someone else. So then using of this list is prohibited. Why? Because this will slow down your entire software. Then you can just propose this plan, convert that into a NumPy arrays. Then because NumPy arrays are more faster, as I told, it's a 50% faster than cut up compared to a list. We can just utilize this one. N-dimensional means we can always go with a different dimensional. So it's a list inside of its dimension is nothing but an arrays inside of arrays only. How many arrays you are creating in the one particular array, that we can take it as an n. Like if we are going with going to create an five deeper arrays inside of one array, it is going to call it as an 5-dimensional. That's it. This is not something else. Okay.
So
So
in real
in real
case,
time,
do we get this 5-dimensional array with only one list or one array, so that which
no.
is deeper to the file level? So what how means what is the use case for that?
No, it's very rarely you will get those kind of things. I'm just going to show the examples of those parameters. So
Okay.
you should have the understanding of those parameters, right? So we don't know. As of now, I haven't get any situation as of now. Maybe you will get it in future if you are becoming a good like ML developer. Okay. If you are not data scientist, if you are going with an ML developing, you are going to develop any a new machine learning algorithm itself. Okay, if you are going with any research kind of thing, in that case, this might work. Okay, as of now, we are just using the algorithms, whatever it is already developed. Sometimes some people just went for some research industries like to develop a different model itself, different algorithm itself. Then you can utilize this sort of knowledge. Okay. So mostly we are all using for two-dimensional array only. Why? Because it's in the table format. You can see 1 4 is in a one column, 2 5 is one column, 3 6 is one column, 4 7 is one column. Here the schema is missing. Schema is missing means the column names and data types of those columns is only missing things. Okay, but it looks like a table, right? Two-dimensional array. So that's why two-dimensional array we are always call it as it's in the format of rows and columns. And this two-dimensional things which we are going to use it in a relational database. Okay. I'm just going giving a glimpse of on like dimensions of arrays. Because we are just going from the scratch to some advanced levels. Okay. Did I answer your question?
Yeah, Vikram, thank you.
Now, indexing. So indexing is same in a list and as well as NumPy arrays. You can always provide the index position to retrieve the elements. Okay, here you can see we are just shown that example to right here. How I can retrieve this 1, 2, 3, 4 first level of array. So here you can see this is first level, one array. In the second level, how many arrays we have? Two arrays, right? How I can retrieve a first array out of that? So this 1, 2, 3, 4, this is the second level array. So in the second level of arrays, this is the first array and this is the second array in the second level. What is the index position for this array? Come on, you guys are already aware of that. Huh?
Zero.
Zero. Yeah. So you can use that index position to retrieve that array. So you can see that 1, 2, 3, 4, we are retrieved that. We just take out from that a first level of array. Now, if you really wants to retrieve the element item is 4, how you can retrieve it?
Zero. Half.
Dot index.
Zero
Four.
again.
Dot, yeah, or
3.
three
One more,
index.
one more square bracket. It mentioned the index.
Three. Yeah, 3.
The same. So you need to just go with the level by level. Okay, you cannot directly go and say that the exp of 3. It won't work.
Yeah.
Otherwise, it will
So,
just giving any error. It means it's a list out of index. Why? Because here, as per Python, we have only two lists. So one is at the 0th position and another one is at the first position. If you provided exp of 3, then what happened? It is going to check, do we have any other list, any other items on the third position? Then here in this case, we don't have it, right? So that's why it will simply throws the error. So in this way, you need to retrieve the level by level. Okay. So one big array is in the first level. Now next, it's in the second level. In the second level, then you should go for a third level. So in the third level, we have that the value 4. Okay. In this way, you need to retrieve. You need to extract the values items out of that n-dimensional arrays.
Can we get the
Okay.
length
So
of
by
the array?
using that index concept, what do you mean?
Can we get the length of the array?
Yes, you can always use a length function. Okay,
Okay.
some of the Python function always works for that.
Okay.
exp2. What is the expected result?
3.
2.
Oh, sorry. 2. Sorry, 2.
Yes, 2. Now I'm going to again it's coming. Now I'm going to retrieve only this first level. Say in the second level, I'm going to extract the 0th position array. Okay. Come on. Okay. So now what is the expected result?
4.
Exactly. This is how you can find the length of those arrays. Okay. Okay. And you can convert that as from input NP array to list as well. So if you really want to convert it, you can convert into a list. Or if you really want to convert into a tuple, you can convert it. Or if you really want to convert that into a set, you can convert it. Okay. Let me convert this into a list. See, that array gets converted into a list. In this way, you can do the conversion as well. Okay.
Sir, it will be a new list created or the existing array will be updated or modified?
Existing one will be get modified. So here exp0 we are just extracted it, right? Then you can store it into any of the variable name like exp3. Okay, this will be remains as it is. But here we are just extracted one out of that, and we are just converted into that into a list, and we have saved it into exp3. Whenever I'm going to check this exp3, it's a list. So you can do all the list operations. Okay.
Okay.
Then by using that index position, if you really want to add these two arrays, what is the expected result by adding these two arrays? 4 plus 1 is 5, 5 plus 2 is 7, 6 plus 3 is 9, 4 plus 7 is 11. So you can always use this index position and our mathematical operators. Okay, that is plus additional operator. You can use it to add those two arrays and convert it into one array. You can always do that by using the index positions. Okay, additions of two matrices. Okay. Any questions? And you can use the slicing as well. If you really want to take the values from in order, like from starting point to ending point, that you can always provide it. Okay, most of the Python functions will works. Okay, then only the things is once it is created. Okay, once it is created, so if you want to modify it, then you should go with some sort of numpy arrays only. See here, if I call this append, this is not coming. Why? Because this is not a list type. Okay, this is not a list type. This is a what I can say, a numpy arrays. So there have numpy arrays, they have own set of functions that you have to use it. Okay, so you can say cumulative sum, cumulative product, and copy, conjugate, compress. Those are the some complex logic behind that. Those are the very in-deep mathematics, in-deep statistics of that. So you guys get like what is cumulative sum, what is conjugation, what is complex, all of these things when it comes to our statistics section. Okay, so by using this Pythonic way, you can achieve it. Okay, those formulas and everything is already defined. If you really want to see the maximum, mean, minimum, n-dimensional, all of the things, it is available. Okay, if you see rounding function is also available, or reshape it if you really want to do the reshape, all of the things, and if you really want to check the shape, size, and if you want to do the sorting, everything is available. So based on your requirement, you need to search it and you need to use that methods. Okay. And yep, if you really wants to check the data type of your inputs, you can always check that is input. And you can also provide some string input as well, but only if it will accept. Just a second.
Oh,
Yep. So you can also provide some string inputs as well. Okay, just to store your string data in arrays. Okay, I'm just showing some examples having a string as well, but mostly it is all using for only a numerical data sets. Okay, you can always check the data type as well, that is U5. And so how we can see the data types? What are the data types available in the array? So you can see these are the list of data types. You can see that integer,
yeah,
boolean,
data types list of I is integer, B means boolean, U means unsigned integer, F means float, complex float, time delta data type, object string, Unicode string, fixed chunk of memory for other type.
hello, somebody is telling something. Okay, so these are the data types available in the NumPy arrays. So that is integer, boolean, unsigned integer, float, complex float, time delta, date time, object string, Unicode, and fixed chunk of memory for other type, that is void. Okay, these are the data types available. If you really want to provide the data type for that, you can always provide it. Okay, you can see if you are provided it as a string. Okay, this will show it as a string as well. Okay, in the same way, you can just provide the data types as well. Like whenever you are just printing in a data types, if you see that U5, something like that, it's a Unicode string, but the 5 means it is in the particular level. Okay, like how many bytes, like in the backend, how many bytes it is get stored. It will shows that information. Okay, that it is not required at this moment, but you can just see because here we are not provided any of the data types, right? By default, it is Python is going to understand as it as it's a Unicode string. Whatever the input which you are providing, okay, let's say here it is providing it as an int 32. So 32 is means integer values, it is 1, 2, 3, 4, having storing within a 32 byte, okay, in its memory. Instead of like if we have a big integer values over here, then it's going to convert it into a 64-bit. So like that it goes on. Okay, so this is the like just a list I'm providing. So whenever you are going to check the data types of your items, you can just use this one. Okay, if it is provided it as I, it's an integer, the same kind. Any questions so far? Okay, then so you can always check the shape of your input. See here, 2 cross 4. You can see 2 rows, 4 columns. The same way. Okay, you can always check the shape as well. You can see 8. So it's a single dimensional array, right? So we have 8 elements, 8 columns. You can see, you can consider in the column format 1, 2, 3, 4, 5, 6. 8 is not available, 9. Okay, which means 8. Okay, you can always check the shape as well. What this reshape can do, what this reshape method can do. So here I've just given example as array.reshape 2, 4. What it means? Okay, what it means. So we have this list, we have this array. I'm just executing this line of code and array. Okay, I want to convert this into another data shape, another shape. I wanted right now it is in a 8 cross 0, right, cross 1, right? I wanted to convert it into a different shape. What is the possibility of the shapes in matrix? Let's say you have 8 elements in a row. Okay, by using that 8 elements, how you are going to convert it into matrix? Forget about Python. Like in the matrix, like how we can convert on which shape we can convert it and how. You can always see here 2 cross 4 or 4 cross 2. You can just check the results of multiplication is 8, right? 4 cross 2 is 8. 2 cross 4 is also 8. It means how many elements we have here? How many items we have? 8 elements we have, right? So only possible shape could be 2 cross 4 or 4 cross 2. If any multiplication values we have that should be resulting is a 8, then you can use that as a reshaping one. So you can say I'm just always providing that as a 2 cross 4 or 4 cross 2 also you can provide it. See here, 2 cross 4 I provided. What is the result? 2 rows and 4 columns. 1, 2, 3, 4 and break it down and the rest of will be coming to on the next array. This is how you can reshape it. Okay, you can see 4 cross 2 is 8. Total elements we have is 8. Here if we missed one element, okay, if we missed one element, it is not possible to reshape it in the 4 cross 2 or 2 cross 4 like that. So again, you need to check how many elements we have. 7 elements. What are the possible permutations to get the results as a to get the product as a 7? What are the possibility we have? 1 cross 7 or 7 by 1. So we can't reshape it, right? So in this case, can't reshape it. If it is 8, 9, 10. How many items we have? 10 elements we have.
10 items.
What is the
10
possibility?
2
5 cross
cross
2 or 2 cross 5. That is the one. 10 cross 1 or 1 cross 10. That is the one. And what are other
5
possibilities?
cross 5. 5. Oh, sorry. 5 cross 2 already done, right?
Yeah. 2 cross 5, 5 cross
0
2.
into 10.
0 into 10.
0 into 10 possible, sir?
10 into 0. What is the result? It's a 0 only, right?
0. Sorry, 0, 0. Sorry. Okay.
Okay. 1 cross 10 or 10 cross 1 is possible. So
Correct.
1 cross
Yeah.
10 and 10 cross 1, it is already there. There is doesn't
Yes.
make any sense to reshape it. So 5 cross 2 and 2 cross 5, that makes sense to reshape it. So let's try with that. So I'm just going to change this to 5 cross 2. See now, 5 rows, 2 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm just swap this one to 2 cross 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see 2 rows, 5 columns. So this is how you can reshape it by using this reshape function. Okay. This is some good examples over here. And so you can always see multiplications of two matrix. That also you can do it by using your our mathematical operators, and concatenation also you can do that. Okay, if we really want to do the concatenation of those two arrays, let's say 1, 2, 3, 4, and here we have already 2 dimensions. Like if only it is possible if the dimension is matched. Okay, it is not possible to give a 1-dimensional array and 2-dimensional array for concatenation. Okay, please keep in mind that. So concatenation also you can do that, concatenation A and B transformation. T means doing the transformation. Why? Because this is in the 2-dimensional but in the different order. Okay, so that's why we are just doing the transformations. T means it's just a transformation. It is just going to reverse the order, like how it is looking. It's just reversing the order. Means if it is in the 5 cross 2, if I do the transformation, then the shape gets changed to 2 cross 5 in this way. This is what this T will do. Okay, and axis you need to provide, as I already explained. Axis 1 is in the row level, 0 in the column level. That's it. So if you really wants to do the concatenation, you can do that. So this is how we have this NumPy functions. You can always see what are the functions we have in the NumPy. Absolute, you can see absolute function also you can create, add, all, and max, a minimum, angle, append, arrange. Have many more functions we have. Some of mathematical functions also we have, np.sum and np dot some of other functions also we have mathematical functions. So you can see cosine function, or tan function, sine function, all the mathematical functions is available. So that's why we are calling it as a NumPy, NP as a numerical Python. For numerical data, whatever the operations which we want to do, all the operations which we can do, because this NumPy will provide all the calculations functions together. Okay. And transformation, you can do the sort as well. So if your array is not at sorted, you can just do the sorting as well. Okay. So at this moment, I'll take a pause now. I don't want to push all the things in one time. Okay. I'll just share this notebook with you all after this class. Okay. Just make a practice of whatever you learned today. Okay. Just get understanding and just clarify your doubts. Then we will move ahead with like how we can create a random numbers, numpys, and how we can arrange it. All of these things we'll see it in the next class. Any questions?
So Vikram, last time you shared that sheet, there were some programs at the end. Do we have to reproduce from our own logic, or they were just for us to just view them?
Yes. So that is what those are the functions which may ask in the different interviews actually for different candidates.
Okay,
Okay. That's all for your interview purpose.
okay,
Because when you got set in front of interviews, they will directly going to ask to write the codes with these
okay,
programs. Those are the most commonly used programs. If you are able to do the same things within a different logic, then
uh-huh,
it will, what I can say, it will shows your confidence level. Then it means you are ready ready for the Python interviews. If you are
okay,
going to write your own codes to achieve the same thing.
oh, perfect, got it.
Yeah. So you can, it's for your practice, you can just make a practice of those things. Because that whatever the course which I have given, so that will shows all the Python basics logics that will shows. Okay, then until that, tomorrow also we are joining at the same time. Okay, until that, take care. Bye-bye.
Bye bye.